Hi, welcome to another video. So, there is a new local model trending on Hugging Face right now, and it has one of the longest names I have seen in a while. It is called Gemma 412b, Agentic Fable 5 Compose. Yes, that is the actual name. But for this video, I'm just going to call it Gemma. As I'm recording this, the model is sitting near the top of the Hugging Face trending list. It has already crossed 6,000 downloads and received around 200 likes within its first couple of days, so naturally I thought I should try it and see whether it is actually as good as the model card makes it sound. And the claims are quite interesting. This is a fine-tuned version of Google's Gemma 412b Instruct model, and it is specifically tuned for coding, terminal work, tool use, reasoning, and multi-step agentic tasks. The creator describes it as a small local coding and tool-using agent that can read the available information, reason about it, use tools, make changes, and then verify its own work. Everything runs locally, so there is no API cost. Your data can stay on your machine, and you can even use it offline once the model is downloaded. It is also released as a GGUF model under the Apache 2.0 license, which makes it quite easy to run through apps like llama.cpp, Ollama, and LM Studio. The headline benchmark claim is on Tau2 Bench Telecom, which tests multi-step tool use. According to the model card, the original Gemma 412b model scored around 15% across 20 tasks, while this fine-tune scored around 55% under the same local test setup. That is where the 3.5x part of the model name comes from. The creator claims that this fine-tune is roughly 3.5 times better than the base model on those technical agentic tasks. Now, take that with a grain of salt. This was a small 20-task local evaluation using Q8 versions of both models, and the creator explicitly says that the results are not directly comparable with the official Tau2 leaderboard. It is useful as a relative comparison with the base model, but it is not proof that this little 12b model is suddenly competing with frontier models. In fact, the creator says that large frontier models can score above 90% in the same general benchmark area. They also admit that this fine-tune scores a little below the base Gemma model on MMLU Pro, which measures more general knowledge, so this is a specialized model. It is supposed to trade a little general-purpose knowledge for better coding and agentic behavior. If you want a general chatbot, this may not be the right model. If you want a local coding model that can attempt tool calls and terminal-style workflows, that is where it is meant to be interesting. There are 4 main quantizations available. The smallest Q3KM version is around 5.7 gigabytes. The recommended Q4KM version is around 6.87 gigabytes. Q6K is around 9.11 gigabytes, and Q8 is around 11.8 gigabytes. I would start with Q4KM for most machines. It is the recommended sweet spot, and it should give you a reasonable balance between memory use, speed, and quality. You can also add the recommended sampling parameters. Set the temperature to 1, top P to 0.95, top K to 64, and the repetition penalty to 1.1. That last setting is important because the model creator says that missing repetition penalties can cause broken output or repeating strings such as 00000. Once that is done, open your terminal in the same folder and run Ollama create Gemma 4 Agentic-F model file. After Ollama creates the model, run Ollama run Gemma 4 Agentic. And that's it. You now have the model running locally through Ollama. Because this uses a new Gemma 4 architecture, I would also make sure that Ollama is fully updated before importing it. The second option is LM Studio, and this is probably the easier route if you prefer a graphical interface. Install LM Studio, download the GGUF file from Hugging Face, and import it. You can do that from the app or from the terminal by running lms import, followed by the path to the GGUF file. Then, load the model in LM Studio and use the same sampling settings. Temperature 1, top P, 0.95, top K 64, and a repetition penalty of 1.1. At this point, you can use the model as a normal local chat model. If you want to connect it to another application, open the developer section in LM Studio and start the local API server. You can also do this from the terminal by running lms server start. LM Studio exposes an OpenAI-compatible local API, so a lot of editors and coding tools can connect to it without needing a paid API key. For example, you can connect it to ZED. If you're using Ollama, make sure the Ollama app or Ollama server is running. Open Zed, go to the model selector, and Zed should automatically discover the models installed in Ollama. Select Gemma 4 Agentic, and you can use it through Zed's agent panel or inline assistant. If you're using LM Studio, start its API server first. Then open the model selector in Zed and choose the model from the LM Studio provider. One thing to remember is that Z8 uses a context length of 4096 tokens by default with Ollama. You can increase that in Zed's language model settings if your machine has enough memory. Something like 8,122 tokens is a sensible starting point, and you can go higher if the model stays stable and your hardware can handle it. So, the setup is not particularly difficult. The harder question is whether you should actually use this model every day. And honestly, based on my testing, I do not think it is reliable enough to be a daily driver right now. It is quite a bit buggy. Sometimes it works properly, follows the request, and gives a surprisingly good answer. At other times, it can produce strange output, get stuck, repeat things, expose special tool-related tokens, or simply fail to complete the workflow in a useful way. The model card says that many of these problems come from the client or sampler configuration rather than the weights themselves. For example, leaked tool call or channel tokens can happen when the front end does not properly understand Gemma 4's native tool format, and that may be true. But from a practical user's perspective, the distinction only matters so much. If a model needs exactly the right runtime, chat template, sampler settings, and tool parser to behave normally, the overall experience is still buggy. This becomes especially noticeable when you try to use it as an agent inside an editor. A normal one-shot coding question is fairly simple, but once the model has to inspect multiple files, call tools, make changes, read the result, and continue for several steps, reliability matters much more. That is where I saw the biggest problem. I would not trust this model to work through a large repository or make important changes without carefully watching everything it does. However, I also do not want to dismiss it completely, because there are places where it is genuinely quite good. For one-shot chat tasks, focused coding questions, small code generation requests, explanations, refactoring a function, or asking for a self-contained solution, it can work well. And when it works, there are moments where it feels better than you would expect from a 12B local model. It can sometimes be more persistent than the base model, and it occasionally handles a technical prompt in a much more useful way. So, I can see why people are interested in it and why it is trending. But the phrase here is, when it works. The good outputs can be quite good, but the consistency is not there yet. For daily agentic coding, I would still use a more reliable model. For experimentation, quick one-shot tasks, or simply seeing how far a 12B local model can go, this is definitely worth trying. The creator is also already talking about a V3, so hopefully the next version improves the stability and reduces some of this flailing and broken behavior. This is an interesting local model with an ambitious goal. It is free, private, relatively small, and sometimes surprisingly capable. But it is also quite buggy, and I would not recommend relying on it for serious daily work yet. So, give it a try through Ollama or LM Studio, connect it to something like Zed, and test it on your own tasks. Just keep your expectations realistic and double-check everything it does. Overall, it's pretty cool. Anyway, let me know your thoughts in the comments. If you liked this video, consider donating through the Super Thanks option or becoming a member by clicking the Join button. Also, give this video a thumbs up and subscribe to my channel. I'll see you in the next one. Until then, bye.